Hey guys, how are you? So I already got my spindle load gauge set up. See, I milled me that piece of frame over there. Hope you can see it. So mount it, like I said, on that hole over there, on that square tubing or whatever. And I went ahead and mounted my stack light. It's not working now because I didn't have the volts that it takes. So this is one of those 15-minute work that you say I'm gonna do it in 15 minutes. It takes 3 days. So that's this is one of it. So I already milled something. So I'm running kind of bigger chips. I write that code over there. That's like a facing on one direction pretty much. Climb milling, about 120 thousandths depth of a step over, 1 inch depth of cut, and I did it at 200 inches a minute. Hope you see it around here, but I'm only at 60 inches a minute. Actually, it's it feels loaded. And I went back there and I already hit around 10 amps on that one leg that I'm checking at. I'm gonna rerun it for you to see it. The point here is not to see how much the machine can actually cut. The point here is to tune that gauge related to the actual amp meter over there on the back that we have over there. So like I said, so I set up the gauge, the stack light is put in. I changed this power cord here, whatever, it was hanging, so I cut another one and put it over there. Oh, there's a way I'm bringing information from that whole pipe besides the Ethernet cable. So what I did, I used, let me show you what I used. Use one of these DB25s connectors, a male and a female. I mounted a male, I believe, either one of them on the inside, and I'm gonna show you now, and the other one on the outside. They match pretty good. Let me see if I can pull it off. The only thing hooked here is the gauge, and it looks like the factory one pretty much. They used to be the serial port. That's what it says here on the tag. Serial port 1 and 2. So I just took one out. The factory one should be somewhere. Okay, this is what it was over there. So it's some kind of serial connection or whatever. So I took this one out and mounted one of this. Looks like this on the inside, like that. Okay, and I'm only using like 4 pins. Just plug it over there, put it in place, and that's our connection for our stack light and also our spindle load gauge. Other than that, the resistor that you saw in the previous video is already on the wire in here. I don't want to take this off because I gotta unscrew this. So the resistor is already on the wire with a heat shrink, and it's this one here coming all the way from the machine all the way here. And I set my output value on that analog output. I already set it to 275%. So it's a little bit more than 250 because I already ran it and I saw what it did. We're gonna run it now, and we're gonna come here, we're gonna look at that number, I want you to see the amperage that we're putting out over there. So let me go ahead and send it. It's putting out some pretty good chips. That's not even a new mill, I mean M mill, whatever. That's the one I did there. But if I use a new one, it's pretty much cheating. So I want to take it to the limit, to the higher limit, then so I'm always on the safe side. So like I said, I'm on 30% of 200 inches a minute. See, and we are gonna, let me regen this to make sure, because I already read 0 over there, and let's run it. Well, those are pretty good chips. This is what we got on the gauge. So we on almost 50%. So if we already hitting 10 amps on the peak, so if we're already hitting 10 amps, I'm gonna stop it, run it again. We can do that. We can go back at it. No problem. So we already running, I mean, we already hitting 10 amps on the gauge. I mean, on the amp meter back there, and we are not hitting 50% here. We're still too low. Why? Because I believe this motor calls between 19 and 22 amps. So 50% of 20, let's just put it in somewhere on the middle, 50% of 20 will be 10 amp. So we should be hitting already 50% of a spindle load, right? So I'm going to, and this is gonna work like this. So right now, that output is at 275%, right? So I'm gonna go ahead and turn it up to 300%, right at 300, and let me lower this right at 300. Save this, escape, run it again. It might take a little bit because we gotta reach to that point, but I'm gonna reset it to full speed at so I'm gonna back, regen, reset speed at 200 inches a minute. Don't want to do that. I just want to get close to it. One more. Let's come down to, okay, that's 40%. That's 80 inches a minute. That's a little bit more than what we were, so I gotta drop it down to 30. See, it's still not hitting. gotta keep going up here. I'm gonna go a little bit faster, see what she does. 100 inches a minute. That's heavy. There we go, 50. So right at 100 inches a minute, it's inch and 1/8. I mean, sorry, 1/8 of an inch. The step over, 1 inch dip. Right now we're showing 50%, but we were already showing 50% at 30. At 60 inches a minute here, so we still gotta go higher. So I'm gonna go ahead and go to 350, because my point is, like I said, I want to be on the safe side, not on the danger side, if I can say it like that. So here on that output, I'm gonna go to come here and go all the way to 350. Save it. Escape out of there. Let's see what we get. I'm wondering if I gotta. Let me just turn the spindle on and see if I can see it peaking higher. Yeah, it's peaking higher anyway now. So the setting is working back there. So let me take this off. I'm gonna drop my C. One inch. Here on our DRO. Right at 1 inch. We're gonna zero over there. We're gonna hit stop, so our C-axis goes back up, and we're gonna drop it down to 30 like we had it, so it's 60 inches a minute. We're gonna back this up, regen. So we're at 14 now. We used to be at 13, away from C-axis, and then we're gonna send it again. This is all we're doing. We're just tuning that gauge. I don't like it. I'm gonna put some more to it. Still not hitting that 50% mark at that low, at this amperage. So we already know we were hitting with that setup 10 amp here, so we have to be either 50 or more percent over there. So I'm gonna come here and change that to 400 and save it at 400. Exit. Let's try it again. So we're gonna come back, regen. Let's go. Two empty cuts, and then we're gonna start cutting. So we're at a 50% over, a little bit over 50%. And we are at 10 amp on that cut. Yeah, so like 9 amps. Want to make sure I'm good here. Yeah, we good over there. So, and if we go faster, this will be 80 inches a minute. 75%, right? We go to 100. Right at 75. Those are some chips. That's 100 inches a minute. These are some serious ships. These are not the ships that we were putting out the other day. So these are big ships. So I believe we got a spindle gauge. I mean a spindle load gauge now over there. I can keep looking at it. So now I know if I get to 50%, I'm already half of it. 75 is 75, 100 is 100. I'm gonna stop now. I'm gonna put another piece of stock over there, and I'm gonna rerun it to see if we hit 100% of our load on the spindle. Let me stop and I'll get back. Okay guys, so I loaded another piece of stock. This one is a 3x2 on the Y. I fixed the program, same setup, same speed, set everything. So I'm gonna go ahead and start at 50% of 200, which will be 100 inches a minute. And at that speed, we're gonna go back there and see what we see over there. So theoretically here on the piece that we had before, we were at 75% when we were at 100 inches a minute here, with the same depth of cut, the same step over, all of that. So I'm gonna go ahead and send it. That's 100 inches a minute. They are flying. See what we got over there? That's 75% of our spindle, theoretically. Got here. Yeah, it hits around 12 ounce, 13, 12 ounce. like that. Okay, so I'm gonna increase. That will be to 120. Let's go deeper. That's 100%. Almost. 140. 100 inches a minute. That's 140 inches a minute. Hopefully you see it. Right at 140, we're hitting 100% right here. So I don't know if I should leave it like that or just even go higher so I stay safer. But what I'm gonna do, I'm gonna drop my Z-axis again. One inch. Come on, 1 inch. It's 1 inch. 0. Come back, regain. We are at 13 theoretically. And I'm gonna go ahead and send it at 140, just like when we were hitting 100% on our spindle load, and go back there and see what actual amperage is coming out to that motor. Okay, so let's do this. So 140. But 90% maybe. That's 15 amps. So I really believe we're on the safe side. Stopped it right there. Let's see. Just want you to see the cuts. They're actually what I was telling you. Those are 120,000 step over, 1 inch dip. You can see there's even some shatter over there. But those chips are huge. So the spindle gauge is a big ship. Serious. I mean, they don't even stick together. To be honest, these are the biggest ships I have ever done on a 1/2 inch mill, on a bigger end mill. they look thicker. Yeah. So the spindle load gauge is how do we say that? Just gonna let it rip whatever we got over there. Start over again. And I'm gonna wrap this video up. So the gauge is good. We got it tuned. Remember that 400% number that you saw over there that I put on the drive? That is not for you unless you use a 15,000 ohm resistor on the line going to that gauge, to the Haas gauge. If you do use the same one, and you might have the same drive and all those stuff that you know, you may have to put the same number over there. But if not, you just got to adjust it to whatever motor you have and all, you know, if you got a different motor, all those setups. So but that's what we got. So we got a spindle load gauge now, and machine is getting better all the time. Thank you guys for watching. I'll see you in the next one.